is x to the third plus 125 over x.
Let's do that by synthetic division. Excellent. Nice continuity. And we already know the answer because we know it from factoring, and we did it yesterday. Okay, this is the problem. Let's see how this works with synthetic substitution. I have no idea how this will go. First off, it meets the condition because we're dividing by x plus or minus a number without any exponents or coefficients on the x. All right? So, meets the condition. Now for the trick, I'll make my L shape. The condition is met. What does the trick tell me to do with the plus 5?
-5.
Make it -5. So I put a -5 here. Eli, since you suggested it, what do I have to write as my numbers across here?
Oh, 1, 0, 0, and 125.
Excellent. This represents 1x cubed plus 0x squared plus 0x plus 125 like we did yesterday. Now we bring down the 1.
I don't get the whole 0 thing.
It's like place value. It's the same thing as having, like if you write 1,000,005, there's just the number 1,000,005.
I know, but in what circumstance do you use them?
Do you use place value? Or these zeros? If you don't use the zeros, this technique will assume that you're going from x cubed to 125x squared. You have to indicate that this is sort of the x cubed place, and this is the constant term
I'm
place.
just talking about also long division.
It's the same purpose for both. It really works exactly like placeholders in Roman numeral, in modern numbers.
Okay, I don't completely get it.
It's like the difference.
We'll chat about it
The
later.
difference between 1 and like 11 and like 1,000.
Difference between 11 and 1,001, exactly. If you don't have zeros as placeholders, you can't tell the difference between 11 and 1,001. If you don't have zeros as placeholders here, you can't tell the difference between x squared plus 125, x plus 125, and x cubed. You got the answer. Can we go through the process?
Sure.
Sorry, good question, Maya. Good question. Okay, -5 times 1 gives me -5.
Did you just get up?
All right, don't give up yet. What's 0 plus -5? -5. What's -5 times -5? Positive 25. Right number for articulation. This gives me 25. What's -5 times positive?
Negative.
Negative 125.
-125, giving me a remainder of?
0.
So this is now because we divided a cubed by an x, that actually lowers my answer by 1 degree from the numerator. So this is going to be 1x squared minus 5x plus 25.
Yay.
Same answer we got as yesterday, and it also fits the factoring pattern from last week of x cubed plus 125 can be factored to x plus 5 times x squared minus 5x plus 25.
Yeah.
Woo! I'll do one more where we don't know the answer, because I really want to get a remainder one.
Do they all add up to 0?
Now, that's why I want to do one with a remainder.
Okay, good.
This one I pulled out of the book, so it had a remainder of 0 for the example. This was one we did last week that we knew should have a remainder of 0, so it was an excellent check. And now I'll do one. I'll go over here and do it. I'll do one that I'll make up, and if it doesn't have a remainder, that will be really random.
I'm very happy.
So I'm just going to, I'm glad you are. So I'm just going to do I'm going to do 3x to the 4th.
Ew.
You may need a calculator for this one. Plus 2x cubed minus x squared plus 4x minus 5
Why do you hate us?
divided by. Okay, it's got to be x plus or minus a number. If the number's too big, this will be ugly. What should it be? X plus or minus what?
72.
1. There you go. 72 would make it interesting. Plus or minus 1, Cody.
But do we want it to be interesting?
We'll make it a little more interesting. We'll make it minus
It's not
2.
going to get too interesting, guys. I don't want to be able to follow this.
All right, let's make it x minus 2. That should make it somewhat interesting. Now, that would have been more, 72 would have been more interesting, you're right. Does this meet the condition that we said?
Yeah.
Yes. And then the trick says to change it to, from minus 2 becomes plus 2 here. I fill in my coefficients, 3, 2, -1, 4, Negative 5. I bring down the 3. What is 2 times 3?
6.
What is 2 plus 6?
8,
8. 2 times 8?
16,
Negative 1 plus 16? 15. 2 times 15?
30.
Add that, I
This
get
one has a
34.
remainder. This one has a remainder.
This will definitely have a remainder. What's 2 times 34?
68.
68, very good. I add negative 5 to 68, and I get 63.
Yeah.
Okay, so what this tells me is my answer, we started with x to the 4th, we divided by an x, so we're going to get
3x cubed.
3x cubed, very good, plus
2x.
8x squared, plus
15x,
15x, plus,
34.
with a remainder of 63, which we will write as plus 63 over x minus 2.
Oh, so it's very simple.
I think so. You may wind up needing a calculator for some of these. If we had done, for example, x minus 72, I would have needed a calculator by about here. Okay? So if the numbers are ugly, you want to have a calculator handy just for the 4-function calculations. Yeah, and that is synthetic division. It's, yes,
Walk in front of that so I can go on YouTube?
sure, come on up.
No.
No? All right, yes. Okay, so yeah, that's, any questions on synthetic division?
Can we start our homework?
Can I start your homework?